Okay, so today we're going to be talking about the binomial theorem, which is just a theorem for multiplying out a plus b to the n, or anything plus anything to a power. It's just got to be two terms. And so one thing we'll notice to start off with here is the formula starts at 0 and goes to n. So if we were doing a plus b to the fifth, we'd have 0, 1, 2, 3, 4, 5 terms. So a fourth power is going to have 5 total terms. And what we have here is we always want to take our n, choose r is the term number. Remember, it starts at 0. And then we take a to the n minus r times b to the r. And then we have to go through that for 0, for 1, for 2, for 3, for 4, and for 5, up to whatever n is. Now this n choose r thing, you have a couple of ways to compute this. The first one you talked about on Monday was to look at the Pascal's triangle. And so in Pascal's triangle we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, just looking at adding up two terms above to get the term below. Now, on these, you got to pay attention to the rows. So since everything here starts at 0, if we, for example, were just doing a plus b to the fourth, we'd want the fourth row. That's actually going to be 0, 1, 2, 3, 4. So you always start with 0 on these. So 0, 1, 2, 3, 4. If we wanted, for example, the third term in that row, again, 0, 1, 2, 3. This would be the fourth row, third term. In other words, 4, choose 3. 4/3. 4, choose 3. Why do I keep putting the fraction there? 4, choose 3. Now we can also use this formula here, which lets us compute this without having to draw out the whole thing. So if I wanted to compute 4, choose 3, I'd have 4 factorial over 3 factorial times 4 minus 3 factorial, which looks like 4 times 3 times 2 times 1 over 3 times 2 times 1. 4 minus 3 is 1, so times 1. And we'll notice the 3, 2, and 1 all cancel out, and we get 4. So we can use the formula, we can use Pascal's triangle, or we can simply go ahead and look at our calculator. The math menu has an option for combinations or choosing. So let's go ahead and look at a couple of examples of this. We'll do a simple one first, and then we will jump ahead to a little bit more complicated. So we have x plus y to the fifth. So our choices here, we could use Pascal's triangle and find the fifth row, or we could use our combinations. So we're going to go through and I think just use the combinations. So our first term is going to be 5, choose 0, times x to the fifth, y to the 0. What's going to happen here is this x term is going to start at 5. You'll notice in our original one, we start at the n, and we subtract whatever r is. Here, r is 0, so we're subtracting 0. And the y term starts at whatever r is, and as r goes up each term, it's going to get bigger. So really, this is 5 minus 0 times y to the 0. That's our first term. Our next term is going to be 5, choose 1, x to the 5 minus 1 is 4, and then y now to the first power. Then we've got to keep going. Not sure why my pen stopped working. Okay, got the pen working again. So first term, second term, our next term is going to be 5, choose 2. Now we got x to the third, y to the second. When we're going through these, just up on the x every term, the y term is just going, x term is going down, y term is going up. So 5, choose 2, x to the third, y squared. Then we've got 5, choose 3, x squared, y to the third. Next term will be 5, choose 4, x to the first, y to the fourth. And then 5, choose 5, x to the 0, y to the fifth. Now we're going to go through and simplify all these. We could use the formula on something like this if we want, and I'll go ahead and just do these off to the side, or down at the bottom, I guess. So 5, choose 0, if we're looking at that, our formula tells us that that's 5 factorial over 0 factorial times 5 minus 0 factorial. 5 factorial over 5 factorial just cancels out, and we get 1. Now, if we think about this as what this actually means, this is the number of ways that we could choose 0 things from 5, and there's only one way to choose 0 things from 5. Think about it in terms of what we did on Monday with the coins. This would be the ways of flipping a coin 5 times and getting 0 heads, which is, of course, one way. So we have 1x to the 5th. Y to the 0 is just 1, so 1x to the 5th. Then we have 5 choose 1. Again, we could use our formula here if we wanted to. 5 choose 1 is going to be 5 factorial over 1 factorial times 5 minus 1 factorial, which is 5 times 4 times 3 times 2 times 1 over 1 for the 1 factorial. And then this is 4 factorial, so 4 times 3 times 2 times 1. You'll see all these cancel out, and we just get left with 5. So here, 5 choose 1 is 5, x to the 4th, y to the 1st. Carrying on here, 5 choose 2. Go ahead and do that down here a little bit further. 5 choose 2 means we're going to take 5 factorial over 2 factorial times 5 minus 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 times 1, which is 2 factorial. And then here we have 3 factorial, which is 3 times 2 times 1. And so again, we'll look for things that cancel out 1s, 2s, 3s, and we have 20 divided by 2, which is 10. And so here we have 10, sorry, that's terrible, x to the 3rd y squared. Next up, 5 choose 3. You're going to start to see something here which is pretty interesting. And think back to the coins. The number of ways we could flip a coin 5 times and get 2 heads is actually the same as the number of ways we can flip a coin 5 times and get 3 heads, because tails and heads are pretty much the same thing. So on top, we're going to see 5 times 4 times 3 times 2 times 1 again. On the bottom, 3 times 2 times 1, and 2 factorial is 2 times 1. And you'll see 3, 2, 1, 3, 2, 1, 10, or 20 over 2 is 10. So we get the exact same thing. And you'll notice that from Pascal's triangle too. The rows are symmetrical. If we look down here, our next row here would have been 1, 5, 10, 10, 5, 5, 1. Scooted them over a little bit there, but symmetrical rows. So we have 10 x squared y to the 3rd. And if we follow that along, 5 choose 4 is going to be the same as 5 choose 1. So 5x to the 1st, y to the 4th, and 5 choose 5 is actually the same as 5 choose 0, plus 1x to the 0, which we don't need to include, because that's just 1, y to the 5th. And so this is all multiplied out. It might seem like a lot of work, but it's way easier than actually taking that and multiplying it 5 times. We'll do one more quick example here. This one just to the 4th power, because getting much higher is annoying. So here we've got 4 choose 0. The difference here is now or a and b are not just single numbers. A is going to be 2x, and b is going to be negative 3y. So we have 4 choose 0 times 2x to the 4th times negative 3y to the 0 plus 4 choose 1, it's not a fraction, sorry, times 2x to the 3rd times negative 3y to the 1st plus 4 choose 2 times 2x squared times negative 3y squared. Again, the x terms, the a terms are always just going down 1. Y terms or b terms are going up by 1 each time. Plus 4 choose 3 times 2x to the 1st, negative 3y to the 3rd, and 4 choose 4, again not a fraction, sorry, times 2x to the 0 times negative 3y to the 4th. So we can go through and use these with the Pascal's triangle if we wanted to. Remember, this is the 4th row, 0th spot. We look at our column, our thing here, 0, 1, 2, 3, 4. 4th row, 0 spot is 1. 2x to the 4th, 2 to the 4th is 16, so times 16x to the 4th. And negative 3 to the 0 is just 1. 4 choose 1 would be our 4th row, 1st spot, which is the 4. So plus 4 times 2x squared is, or 2x to the 3rd is times 8x to the 3rd times negative 3y. 4 choose 2, again looking back at Pascal's triangle here, is 6. So plus 6 times, now we've got 2x squared, which is 4x squared, times negative 3y squared, which is a positive 9y squared. Then we'll jump down, start the new row. Choose 3. From Pascal's triangle here is going to be the third spot, which is 0, 1, 2, 3. So 4 again. Okay, stop doing that. 4 times 2x to the first, which is just 2x, times negative 3y to the third, which is a negative 27y to the third. And then we've got choose 4, which is again just 1. So 1, 2x to the 0 is 1, and then negative 3y to the fourth. 3 times 3 times 3 times 3 is 81y to the fourth. Then we can go back through and simplify each of these. That gets a little bit tricky here. And so we have to just multiply all these terms out. 16x to the fourth. 4 times 8 is 32. So 32x to times negative 3. Sorry about that. So 32 times 3 would be 96. But it's negative, so minus 96. X to the third. Y. Over here we've got 6 times 4 times 9. That's a big number. 216. X squared, y squared. Down here, 4 times 2 times negative 27 is negative 216. X, y to the third. And then 81 y to the fourth.
It's still freezing in here.
And so there we've got that all multiplied out. Again, might seem like a lot of work, but way easier than actually multiplying that.